what? That is 1/7 of u to the power 7 plus 1/9 times u to the power 9 plus the constant c. And now we have to restore the original integral here by substituting tangents instead of u. So therefore, our integral would be 1/7 of tangent of x on the power of 7 plus 1/9 of tangent of x at the power of 9 plus constant c. And that's any questions? Not at this stage. All right. So here is what we just did. Okay. So we covered these cases, but trigonometric integrals might be much more diverse. So in other cases, we don't have such a straightforward, relatively simple rules. So it's really up to all of us in the sense of mathematical intuition about solving. Sometimes we have quite techniques that we covered so far in combination, like integration by parts, using trigonometric identities to simplify things, methods that we covered, like we said, combination between them. So some useful guidelines when we do trigonometric integration is to apply the fact that the integral of tangents of x is natural logarithm of secant absolute value of secant corresponds to c. And the other one is the integral of secant of x is equal to natural logarithm of the absolute value of the sum of secant and tangents. So let's prove here the first one, and then we'll prove the second one. So for proving the first one, what we have here? Our integral of I is equal to tangent of x dx. How can we proceed from here? We need this. Where is tangent of x? Tangent of x is sine of x over cosine of x. So we have sine of x over cosine of x dx. So now if we combine this, we pair with what? We pair with differential of cosine. But we have to change the sign here. So this really is minus sine of x multiplied by minus x twice dx, and this is cosine of x. So now this thing here is the differential of cosine of x, because the derivative of cosine of x is minus sine of x. So that means we pair with the following integral. We take minus in front of the integral, we pair with d of cosine of x over cosine of x. So now if we substitute our cosine of x to be equal to u, then our integral becomes like that, minus u over u. And you know that this is minus natural logarithm of u plus constant c. But our u is cosine of x. So we pair with minus natural logarithm of absolute value of cosine of x plus c. Are we good? This is still not secant, but how can we make it? By applying the logarithmic properties. So that means if we have a constant multiple of the logarithm that is minus 1, we can write our logarithm like this. Logarithm of the absolute value of cosine of x at the power of minus 1, right? Which is natural logarithm of the absolute value of 1 over cosine of x, which is the secant. And this is equal to natural logarithm of the absolute value of secant of x plus c, which is what we wanted to show. Okay. Okay. Any questions about this? No? Third step you mean here? Okay, so like again, the philosophy is that we appear with a trigonometric function which product to the differential of x will give us a differential of another trigonometric. So based on the fact that derivative of cosine is minus sine, that means that technically what we do here is derivative of cosine of x dx is equal to minus sine of x. So that means if I multiply minus sine of x by dx, I will appear with the differential of cosine of x. So just recognize this term, minus sine of x dx, as differential of cosine of x, and I have cosine of x as another argument in my function, which allows me to do the substitution here and to do this. And then from there, after we pair with the integral, we have to use the logarithmic properties so that we express what we want. Okay, so let's prove the other one. Secant of x. The x that is equal to natural logarithm of the absolute value of the sum of secant of tan x. So how we can do this? Okay. Like again, we follow the same logic here. We try to express our secant, which is technically 1 over cosine of x dx, in a way that we can appear with some reasonable substitution that will simplify this integral. So how we should proceed? Maybe, yeah. Don't worry if you don't come up with this. I know sometimes in class is stressful. Like again, the question is not that I want to examine you, but just want to kind of give you a chance to train or look for it. That's pretty much, just not for any marking for anything. So one way that we can do is again to look for some trigonometric differential that will help us to solve this trigonometric function. So one way is if we multiply this by cosine and divide by cosine. This is our function, so multiply by cosine and divide by cosine, so they don't change anything. And then by combining this term, I appear with differential of the sine. And then by combining these two terms, I have cosine squared, which is 1 minus sine. And this way I can substitute v equals sine of x to solve this. So let's see what happens. So from here, we appear with integral of 1 over, say, cosine of x squared, okay, let's have all the steps here, d cosine of x, right, so sorry,